friends. Today we're gonna use 3D printing to solve a real life problem. A lot of times around our house there's things that either don't fit right or we don't have certain organizational pieces in place. So that is generally where I'll go grab a caliper, start measuring things, and figure out how to print whatever I need to solve said problem. In this case, we recently purchased this baby dresser, and the baby dresser was going to be partially on a carpet and partially on the floor, so it wasn't going to sit level. So I could just put felt feet on it, but it wasn't going to raise it up high enough. So then I thought, okay, how could I create like an additional spacer that could also accept a felt foot? So I present the 3D printed solution here. So this wasn't too hard to create. I just measured the foot. I measured the diameter of one of these felt pads and made sure that I gave it enough thickness to where it would raise up the dresser so that it would be nice and level. So let's get into how this is made. The first thing I did was put the level on the top of the cabinet and get a rough idea of how much of an angle there was. I then grabbed my caliper and measured the width and the depth of the leg and took a note of it. One bit I didn't show here is I had my wife tilt the cabinet so that the level on the top was centered, and I then measured how much height I needed to take into account to raise it up. Here we are in Fusion 360. I'm going to show the entire build process here, being that this is somewhat of a basic geometric shape. So here's what we're going to do. And now this is not going to be a rundown on Fusion 360 and the interface and all of the controls. There's a lot of great tutorials out there on the web and on YouTube that can give you kind of a high-level overview of Fusion and how to use it. I'm just going to walk through some of the basics of creating a sketch, doing some extrusions, and then sending it over to our slicer. So to begin, as you saw, I measured the foot with my caliper, so I've got my dimensions here. So the first thing I'm going to do is I'm going to create a sketch. It's going to ask me what plane. I'm going to place it on our floor plane here. Then I'm going to go up and I'm going to grab a rectangle. I want it to be a center rectangle, and I'm going to snap it to the center of our canvas. And as I drag it out here, this particular rectangle, actually I think this is with a center rectangle or a non-center, you can give it dimensions immediately. So we know that we want this to be 49 millimeters wide and 38.75 tall. Okay, so a note, you will learn this, but you need to also understand the tolerance of your printer. The foot of that baby cabinet in this case is not 49 by 38.75. It's about a little over a millimeter smaller. So I'm giving extra width here on purpose so that I know that will fit the foot. And that has to do with when you're printing things on your printer, and let's say that you want to have a square peg fit into a square hole, or you want a square peg to have a square that fits around it, where pieces are fitting together, that is where you need to add additional tolerances. Generally speaking, and this depends on the size of the object that you're working with bigger objects, you can get away with smaller tolerances. For example, I make big wall signs where I have inserts that fit within a certain letter, and I only need like a 0.12, 0.14 millimeter tolerance, whereas something smaller, you generally need more. So in this, I'm giving it at least a millimeter of tolerance. The other thing we need to do here is we need to give it some thickness, so we can hit the O key and we can offset this. And I'm going to make it about 4 millimeters thick, and it's going inwards. We want it to go outwards, so we can flip it. You also could manually give it a negative here. We're going to hit OK. The other thing we need to do is we need to draw out our circle for our foot pad, the felt pad. And these felt pads are about 38 millimeters. So again, we're going to make this, let's make it 39.1 to be safe. And there we go. So we've got our basic sketch here. Now, once we have our sketch, we need to start extruding. The first thing that we're going to do is we're going to create the thickness for the base, meaning like the overall shape. And in this case, my circle went very slightly over the edge, and we need to make sure that we select all these faces. And I'm going to hit the E key, and I'm going to bring this up about 5 millimeters. Now I measured how thick I need this to be while also taking into account the thickness of the felt foot, so that I can get that cabinet to be level. Okay, so next we're going to turn our sketch back on. Fusion turns sketches off generally right after you have made an extrusion. Okay, so now we want to create the cavity in the surface. So we are going to go in here and make sure that we just select the inner rectangle. We're going to hit the E key, and now we're going to do something different. Before we did profile plane, and in this case we're going to do from object, and this lets you select a face and have the extrusion start at that face. And we're going to go -2, and there you can see that it made a cut down. Now the nice thing with this is, and this is why Fusion is awesome, in the bottom of my screen you can see our parametric timeline. Let's say that I needed to change the thickness, but I didn't want it to impact that little recess we just made. Say I make this 10 millimeters, you can see that our inset recess here stayed the same, and that's because we used this top plane as the starting point. So this is really helpful. So when you're working with extrusions in Fusion, be aware of that, because there's a number of ways that you can create extrusions as far as their start point, their end point, and you can even offset them so that they just start at some value offset from where the sketch is. All right, so the next thing is, let's go onto the bottom, and we're going to create the recess for our felt foot. And I need to make sure I get these little bits here. And so for the thickness of the felt foot, the overall height of one of these felt feet that I have is about 4.6, but they will squish a little bit. So, and we need it to obviously stick out of the bottom of this pad, because we want the felt to be what's contacting the floor, not this 3D printed part. So I'm going to go up about half of that. So I'm going to go -2.25. Whoops. So I assumed I needed to go minus, but that's incorrect, because down in this case is minus. So I'm just going to get rid of the minus. And you'll notice that Fusion defaulted to cut, and that's exactly what we want. The last thing that I did was I just added a chamfer to make it look a little bit nicer, and we can go up here and use the chamfer tool. I've added mine to my toolbar. If you don't have that, you just go to Modify Chamfer, and you start selecting your edges. You could also have used a fillet here if you wanted it to be more rounded. And we're just going to drag this in, and about 2 millimeters looks good. We still want to have a little bit of an edge here for some thickness. Okay. So how you get these objects over into your 3D printer, there's a couple of ways that you can do it. You can go over to Utilities, and you can use this Make command. This is useful if you have a lot of components and various bodies. It will allow you to export all of those bodies over to your 3D printer. And you can also do it as a 3MF, which makes it even more helpful as far as organization goes. Luckily, ours is rather simple. We can just go over to our bodies here, and this is the one that we want to send over, and we can right click, save as mesh. And then what you can do here is you can check this box that says send a 3D print utility, and then you've got to select, it's going to open up your Finder, and you got to select your application. In my case, it's Bambu Studio, and if I just hit OK, you saw it flash briefly, but here we go. So now we're in Bambu Studio, and you can see the spacer here on the canvas. So I'm using a Bambu Carbon X1, but you could do this with almost any printer. And the first thing that I'm going to do is make sure that I've got the right material selected. I'm just using some PLA here. It's Polyterra, and it's kind of a tan color, so it'll match somewhat. And then I'm just going to duplicate this because we need 2 of them. And then I'm going to hit the Arrange button on the build plate. The last thing I need to do is I'm going to go over to Others, and we're going to turn on, or I'm sorry, go to Support. We're going to turn on Support. And let's slice this real quick and just see what it looks like. Okay. I think what I'm going to do is I'm just going to increase the wall loops to 3, and I'm going to change the infill to 50. I don't know that I need 100 here. The most important part is the thickness between the felt pad and the base of the foot, which, as you can see here, we're getting solid layers there because that part is not, this area in the middle is not super thick. So this should work just fine. If you wanted to, you could crank it all the way up to 100. I mean, if you look at your total filament usage over here, if I change this up to 100, it's probably going to not impact it a whole heck of a lot. Let's slice it again. Yeah, I mean, minimal. It went from 5.11 to 5.65. So, you know what? Sure, let's just do 100%. The other thing that I do, I've noticed in general in the Bambu Studio that for most filaments, the build plate temperature is a little lower than you can go. Now, I'm not concerned with adhesion in this scenario, but I'm just pointing this out. Oftentimes for PLA, I'll crank this up to like 60 and sometimes 65. If you're using a Wham Bam plate, which would be a smooth high temp plate, they actually recommend on their website to do 75 around there for PLA. Which seems crazy, but it also, with the Wham Bam plates, I tend to use those when I need like some serious adhesion because they work great. Okay, so let's go ahead and fire this off to the printer. All right, here's our 3D printed foot. You can see the felt pad on the bottom of it and the recess on the top. And now we can put the cabinet's foot nicely inside of it and it will hold it secure in place. Last, double check with our bubble level. It's not dead center, but you know what? We're gonna call this good.